Hi, welcome to the flip lesson number 2 for redox reactions, and in this lesson we're going to learn how to add two half equations together and also how to identify something's an oxidant or a reductant, which is a little bit different to being oxidized or reduced. So firstly, adding half equations to make a whole one. So remember I told you that in a redox reaction something is always lost electrons and something's always gained electrons. So we will always have a half equation where something is lost and something is gained electrons. So in this example here, in this example, for the sodium half equation, sodium has lost electrons. Okay, so we can tell that because the electrons are a product of the reaction, so they've been given away. So we've ended up with an ion that hasn't got those electrons anymore. It's lost them. Okay. Whereas on the second one, the chlorine, this is chlorine and this is chloride. Chlorine as an atom and chloride as an ion. We have gained electrons. They're added on the left. Because the electrons are added, we know that we've got oxidation happening for that second half equation. So whenever you've got two half equations, one of them will have electrons on the right of the half equation and one of them will have half the electrons on the left. Okay, so once we have these two redox half equations where one's oxidation and one's reduction, we have to add the two together to make a whole equation. So we want to add this one to this one. Now before we can do that, we have to have the same number of electrons on both sides of the arrow. So this half equation we've got 2 electrons on the left, and this half equation we've only got 1. So before we can add them together, we've got to double that whole of the first half equation for sodium. So that means everything in this half equation we're going to double. So we're going to put a 2 in front of that sodium atom, we're going to put a 2 in front of that sodium ion, and we're going to put a 2 in front of that electron. Okay, once we've done that and we've got the electrons the same on both sides, they sort of cancel each other out. So we're not recording those electrons anymore in the final whole equation. So now we just look at everything that's on the left of the arrow, and to start with we've got 2 sodiums and we've got 1 chlorine Cl2, and on the right of the arrow we've got 2 sodium ions and we have also got 2 chloride ions in the second one. Okay, so that now is our whole equation, and it's duplicated for you here in a more tidy fashion. Okay, so that's the first example. Now you can go and try and do this one, but looking at it first, which one are you going to have to double? The top one and the bottom one. Firstly, let's look at it. Which one is the one that's lost electrons? Is it the sulfur or the ion equation? Okay, it's this one's lost electrons and this one's gained electrons. Okay, and before we can add them together, I need to double the second equation. Okay, so go ahead and see if you can do that in the workbook, and there should be some more examples in there as well for you to practice with. Okay, the next thing is a term called oxidant and reductant. Now, just when you thought you were getting comfortable with oxidation and reduction, as oil rig here, now we're coming up with something completely different. Now, an oxidant or oxidizing agent is not the thing that's been oxidized, it's the thing that's causing the other thing to be oxidized. Okay, so it's in order to have caused something else to be oxidized, it itself is reduced. So we're getting a little bit confusing here, but basically whenever you see an A, like oxidant and reductant, or an oxidizing agent or a reducing agent, then as soon as you see that A, it's anti what you think it would be. So the oxidant is the thing that's reduced, and the reductant is the thing that's oxidized. Okay, so if we go to our oil rig down here, the thing that has been oxidized is the reductant. So we call it the reductant. And the thing that has gained electrons is the oxidant. Now, in the assessment, you will have to write half equations, and you will have to add them together to make a whole equation, like we've practiced. And then once you've got the whole equation, you're going to need to circle what is the oxidant on the left and put a rectangle around the reductant species on the left. So when we talk about species here, species just means either the atom or the ion, and as I say, what's important is these two species that go into the reaction. Now we've got to figure out which is the reductant, and I think it's simplest just to think in terms of if the electrons are on the right, then that equals the reductant. So we want reductant, right, and rectangle. So we're keeping all the R's together. So if the electrons are on the right, it's the reductant. So that means this sodium here is the reductant. So we're going to put a rectangle. We're going to put a rectangle around that reductant species on the left of the arrow. And obviously the opposite's true. If the electrons are on the left, then that's going to be our oxidant. And we're going to circle it. So for the second half equation with the Cl2, the electrons on the left, so that is the species that we're going to circle as the oxidant. So here's an infographic just to illustrate this. So in oxidation, we lose electrons, and the thing that does the losing the electrons is the reducing agent. For reduction, we're gaining electrons, and that means it's now reduced, and the thing that does that is called the oxidizing agent. And that's all for this lesson.